Imagine riding on a beam of light, not approaching it, not nearly matching it, but moving alongside it at its unmatchable speed. What would you see? What would you experience? Would the universe collapse into an instant, or would moments stretch into eternity? These questions are not philosophical flights of fancy, but precise implications of the physics discovered in the early 20th century, formalized through the revolutionary insights of Albert Einstein and later elucidated by Richard Feynman. For light, as defined by the fundamental structure of the universe, time does not flow. To understand this, one must first abandon the centuries-old notion of absolute time. Classical physics, anchored by Newton, assumed time as a universal metronome, ticking identically for all observers, independent of motion or place. 1 second was 1 second everywhere, whether standing still, riding a horse, or crossing oceans. This view held until Einstein reimagined the fabric of reality. In 1905, he introduced the theory of special relativity, resting on two radical principles. The laws of physics are identical in all inertial frames, and the speed of light in a vacuum is constant for all observers, regardless of their relative motion. The second principle, shattered intuition. Imagine chasing a beam of light at half its speed. Classical reasoning would suggest that relative to you, the light moves slower, yet experiment and theory show it remains constant. Light speed does not bend to human perspective. To reconcile this, the universe sacrifices something else, time itself. Time, no longer absolute, stretches and compresses according to motion. This phenomenon, time dilation, dictates that the faster an object moves relative to an observer, the slower its internal clock ticks when measured from that observer. At everyday speeds, the effect is imperceptible. Walk across a room and the discrepancy is too tiny to measure. Accelerate to 90% of light speed and time slows noticeably. Approach 99% and it slows drastically. At exactly light speed, equations dictate infinite time dilation, proper time. The time experienced by the moving entity collapses to zero. Light, always traveling at this ultimate speed, experiences no passage of time between emission and absorption, though technically photons have no frame of reference from which this passage could be measured. Yet mathematically, the interval along a photon's path is zero. Emission and detection are simultaneous in this geometric sense, though billions of years may pass in the universe's frame. Human minds struggle to conceive of motion without temporal duration, but relativity demands it. The intuition that time is uniform and inescapable is a consequence of evolutionary scales, where velocities are minuscule compared to c, the speed of light. Reality, unbound by human perception, moves differently. To formalize this, space-time unites space and time into a four-dimensional continuum. Every object traces a world line through this continuum. Stationary objects move primarily through the temporal dimension. Motion through space diverts some of this progress from time. The faster an object moves through space, the less it moves through time. At light speed, movement through time ceases. Hermann Minkowski reframed Einstein's insights into a geometric model, showing that the space-time interval, invariant across observers, governs all motion. Objects with mass traverse time-like paths with positive intervals, experiencing the passage of proper time. Light follows a null path where the interval is zero. This is the geometric manifestation of time stopping. From this perspective, a photon emitted from a distant star and absorbed on Earth has no journey in its own frame from emission to absorption. No time elapses. Experimental evidence repeatedly confirms these effects. Particles accelerated near light speed in accelerators exhibit extended lifetimes consistent with time dilation. Muons created in the upper atmosphere survive long enough to reach the Earth's surface because, from their frame, the distance through the atmosphere is contracted. Even the GPS satellites in orbit must account for relativistic effects. Their clocks tick at different rates than ground-based clocks due to both their speed and the weaker gravitational field, and without correction, positional errors would accumulate kilometers in a day. These phenomena are not theoretical curiosities, they are operational realities. Feynman emphasized the primacy of experiment over intuition. If the equations match observation, their strangeness is irrelevant. Time dilation is real, and light sits at the ultimate extreme. Its constant speed is not merely a limit, it is the defining feature of space-time itself. The speed of light acts as the conversion factor between space and time dimensions. When an object moves at this speed, its motion through time collapses to zero, and the proper time along its path vanishes. But this privilege is exclusive to light because photons are massless. Objects with mass cannot reach c as velocity increases. Relativistic momentum grows toward infinity, and energy requirements become impossible. The Lorentz factor governing time dilation contains a denominator that approaches zero as velocity approaches c. Energy diverges, no mass can cross the light speed threshold. Light, constrained by its lack of rest mass, inhabits the boundary of temporal experience. Massless particles must travel at c. Any deviation is forbidden by the geometric and physical structure of spacetime. From a photon's trajectory, no time passes, though there is no meaningful reference frame in which the photon experiences anything. This distinction is subtle but crucial. Proper time is a geometric measure, not subjective experience. Quantum theory complements this picture. Feynman's path integral formulation treats photons as exploring all possible paths between emission and absorption, summing amplitudes across histories. Yet the dominant contributions align with classical light-like paths, reinforcing the null interval and timelessness. Massless excitations are fundamental, their motion dictated by the invariance of c. Gravitational effects further entwine with this structure. General relativity shows that mass-energy curves spacetime, affecting time itself. Clocks in stronger gravitational fields tick more slowly. Near a black hole, time dilation reaches extremes at the event horizon. Distant observers see time effectively freeze. Yet locally, a photon crossing that horizon experiences zero proper time, as it always does along a null path. The interplay of mass, energy, gravity, and motion reveals time as flexible, emergent, and relational, not absolute. Light exists at the boundary of this structure. It moves through space without aging, connecting emission and absorption in a single space-time interval. The cosmic microwave background photons traveling over 13 billion years from the early universe exemplify this. From our observational frame, eons pass from their null interval. There is no duration. This leads to profound philosophical and scientific reflections. Time is not a universal river, but a geometric property intertwined with space, motion, and energy. Relativity shows that simultaneity is relative. Two observers moving relative to each other will disagree on the timing of distant events. The flow of time is not universal. It is contingent on motion and gravitational environment. Light traveling along null paths occupies the extreme of this variability. Feynman emphasized the importance of understanding through calculation and experiment, acknowledging that our perception, grounded in low-speed experience, cannot intuitively grasp these extremes. Reality obeys geometry, not sensation. The constancy of light speed enforces time dilation, null intervals, and the impossibility of exceeding c for massive objects. It defines causality, establishing the structure within which events can influence each other without paradox. Emission and absorption are linked along light-like paths. Photons never age. Massless entities exist at the temporal boundary. For humans, bound by mass and constrained within the light cone, motion always carries a temporal component. We move through time inevitably. Light moves along the frontier where time vanishes. This principle underlies the deepest structure of reality. Space-time, motion, mass, energy, and causality converge to make light's experience timeless. The mathematics is precise, the implications are profound. Every photon crossing the cosmos embodies this extreme. Billions of years in cosmic time are compressed into zero proper time. Time as we perceive it is not fundamental. It is a measure contingent upon motion, mass, and gravity. Light is the ultimate witness to the architecture of the universe, moving along the boundary where temporal progression ceases. Our intuition fails, but the equations are unambiguous. The universe allows light to traverse its vastness untouched by time, connecting points across space in a way that defies human perception, yet conforms perfectly to the invariant laws of physics. The journey of a photon is both instantaneous and eternal in the framework of spacetime. Emission, transit, and absorption are one contiguous null interval, a bridge untraversed by seconds or minutes. Feynman emphasized that physics is reality, not intuition. Relativity's consequences may strain understanding, but they describe what occurs. Time stops for light because space-time structure demands it. Its speed is not just a number, it is a cosmic constant, the conversion factor that defines the flow of causality, energy, and motion. Massless entities inhabit the boundary between time and space, their paths revealing the deepest truths about the universe. All other objects endowed with mass experience time because their paths lie within the light cone, restricted by energy, momentum, and geometry. They move through time as inevitably as rivers flow toward the sea, whereas light moves along a different domain, untethered from temporal accumulation. This is not metaphor, it is the mathematical reality of the cosmos. The universe is built with a geometric backbone, and light traces the boundary where the metric that measures time collapses. The concept that time stops for light is therefore not poetic exaggeration, but a precise statement about space-time, proper time, and the limits imposed by fundamental physics. It is a reminder that our everyday experience of time is a narrow perspective on a broader, richer, and stranger reality. The constancy of light speed, the collapse of proper time along null paths, the impossibility for massive objects to reach this frontier, all these facts intertwine to reveal the extraordinary structure of the universe. Light, timeless and relentless, races across the cosmos, linking past and present, emission and absorption across incomprehensible distances in a zero-duration path. The equations that govern this are exact. The consequences, however, stretch the mind. Time, motion, mass, energy, and space-time converge in this revelation. The speed of light is the ultimate metric, defining the frontier between temporal experience and timeless propagation. Every photon that strikes our eyes, from stars or the early universe, carries this profound truth. Its journey is timeless. The universe seen through the lens of light is a domain where time can vanish entirely, where motion exists without aging, where the mathematics of relativity manifests reality in its most extreme form. This is the world that Einstein and Feynman revealed a cosmos in which time is malleable, contingent, and intimately tied to motion, and where light stands alone at the boundary where duration ceases, embodying the ultimate principle of physics.
The geometry of space-time, why only light escapes time.
The statement that time stops for light is only the surface of a deeper geometric truth about reality. To understand why light alone occupies this extreme, one must examine the architecture of space-time itself. Special relativity redefined motion and simultaneity, but Hermann Minkowski later unified space and time into a four-dimensional continuum, where the distance between events, measured not by classical Euclidean space, but by the space-time interval, dictates the flow of time for each object. In this continuum, time is fundamentally different from space, encoded in the metric that subtracts the temporal component from the spatial components, multiplied by the speed of light squared. This difference produces three categories of paths through space-time: time-like, space-like, and light-like. Objects with mass traverse time-like paths, experiencing positive proper time and moving inevitably forward along a temporal dimension. Light follows a null, or light-like path, where the space-time interval is precisely zero. This null interval is the geometric manifestation of light's timelessness. Massive objects are constrained within the light cone, the boundary of causality, which defines the directions in which events can influence each other. Light exists exactly on the surface of this cone, occupying the frontier of possible motion. To move outside it beyond light speed would require violating causality. Relativity dictates that massive objects cannot cross the speed of light because the relativistic energy required grows without bound. As velocity approaches c, the Lorentz factor diverges, momentum and energy tend toward infinity, and time dilation stretches toward infinity. For massless particles like photons, these constraints are bypassed. They travel perpetually at c, along paths where proper time remains zero, and the space-time interval is null. From this geometric perspective, the universe defines motion through a constant speed through space-time. Objects at rest in space progress entirely through time. Objects moving through space divert some of this motion, reducing progress through time. As speed approaches light speed, motion through time dwindles. At c, it vanishes. This relationship is not metaphorical, it is mathematical. In quantum theory, photons reinforce this geometry. Feynman's path integral formulation treats each photon as exploring all possible trajectories between emission and absorption, summing amplitudes to produce the observed probability. Yet the dominant contributions follow classical light-like paths, precisely those with null space-time intervals. Light thus simultaneously obeys quantum uncertainty and relativistic geometry, existing in all allowed paths, yet constrained by space-time symmetry. Massless particles are not arbitrary. They are fundamental excitations of fields, constrained to move at c by the invariance of space-time. Gravitational curvature adds another layer. General relativity reveals that mass energy does not exert force in the Newtonian sense, but curves space-time itself. Massive objects follow geodesics, the straightest paths possible in curved space-time. Time is warped. Clocks deeper in gravitational wells tick slower relative to distant clocks. Near a black hole, time dilation reaches extremes. To an external observer, infalling objects appear frozen at the horizon, yet locally, proper time continues along their time-like paths. Photons crossing the same region maintain zero proper time, reinforcing that massless paths exist at the boundary of temporal experience. The constancy of c links space-time geometry to the preservation of causality. Exceeding c would allow effects to precede causes in some frames, fracturing temporal order. Light bound to c defines the structure of the light cone and the permissible flow of events. Its null path is a direct expression of the universe's invariant causal structure. Light is also the messenger of cosmic information. Photons from the cosmic microwave background, emitted nearly 3.8 billion years ago, traverse the universe, redshifted as space expands. From our frame, they have journeyed billions of years from their null interval. No time has elapsed. Proper time remains zero. Emission and detection linked as neighbors in the space-time metric. This reveals that cosmological scales do not alter the geometric foundation of light's timelessness. Relativity shows that simultaneity is relative. Observers in different inertial frames disagree on the temporal ordering of distant events. Time is not universal, it is relational. contingent on motion, position, and gravitational field. Light's null paths exist at the extreme limit of this variability. Massless excitations, including photons and gravitational waves, are the only entities capable of occupying this boundary. Their motion enforces the invariant speed, preserves causality, and embodies the ultimate principle of relativistic geometry. Energy and momentum encoded in the photon allow it to interact with matter, carry force, and transmit information, yet they do not accumulate aging. The photon is a bridge connecting events across vast distances with zero passage of proper time. Light's timelessness is not subjective, it is a precise mathematical statement about the null interval in spacetime. No frame exists in which a photon can be at rest. Attempts to define a rest frame for light break the coordinate system. Asking what a photon experiences is meaningless. The null interval governs motion, not perception. Light's path is the universal standard of motion in spacetime, defining the maximum rate at which information, energy, and causal influence can propagate. Geometry, not intuition, dictates this. The universe's architecture ensures that all massless entities travel at c, preserving the invariant spacetime metric. Photons traveling along light-like paths exemplify the boundary between temporal experience and timeless propagation. Massive objects restricted to time-like paths experience passage through proper time. Their acceleration towards c brings them asymptotically closer to zero proper time, but never allows them to cross the threshold. This is not limitation but design. The structure of spacetime through the Lorentz transformation enforces these boundaries. Relativity is not merely a theory of motion. It is a geometric framework defining possible trajectories, intervals, and causal influence. Time is malleable, contingent, and relational. Light exists where it disappears entirely. The interplay between quantum mechanics and relativity reinforces this. Feynman's formulation shows that all paths contribute, yet null paths dominate. Interference patterns arise from the summation of amplitudes, but the invariant structure of spacetime ensures that photons do not experience duration. This symmetry is fundamental, not emergent. The speed of light is encoded in the constants of Maxwell's equations, the permittivity and permeability of free space, predicting the propagation of electromagnetic waves at exactly c. Einstein recognized that this is not coincidental. The invariance of c reflects the deep structure of spacetime. Photons' timelessness emerges naturally from this invariance, highlighting the inseparability of light, geometry, and causality. Gravity, motion, mass, energy, and spacetime converge to define how time flows. For massive observers, time is real, measurable, and inevitable. For massless photons, the passage of time collapses, emission and absorption coinciding along a null interval. The cosmic narrative from the early universe to the present is stitched together by these light-like connections. The universe is a tapestry of events, linked by photons traversing null paths across billions of light years, timelessly connecting emission and detection. The laws of physics preserve these structures. Proper time vanishes where null intervals dominate. Relativity's consequences are counterintuitive but experimentally verified. Particle accelerators extend lifetimes. GPS satellites require correction for time dilation. And cosmic observations reveal light traveling across unimaginable distances, undisturbed by the passage of time. The geometry of spacetime ensures that time dilation, proper time, and light-like trajectories are consistent across all frames. Massless particles inhabit the edge of temporal experience, defining the limits of motion, information propagation, and causal influence. The universe enforces these limits with precision. Light, the ultimate traveler, exists along the boundary where time collapses. Its null interval is the mathematical expression of timeless motion, the cosmic standard by which all causal propagation is measured. Everything with mass is constrained within this boundary. Nothing can exceed it. Photons are not merely fast, they are the expression of the space-time metric itself. Every photon in the cosmos embodies this principle. Its journey is both instantaneous and eternal in geometric terms. Mission and absorption, star to detector, early universe to present, are neighbors along a null interval. The universe viewed through light is a domain where time ceases, motion continues, and causality is preserved. Proper time for light is zero, yet energy, momentum, and information persist. The photon's path is a bridge across space without duration, a continuous link connecting events in the cosmic fabric. Gravity, expansion of space, redshift, and quantum uncertainty intersect with this geometry, but the null interval remains invariant. Photons traverse billions of years in zero proper time. This is not a poetic abstraction, but the precise prediction of relativity and quantum theory. Massless particles define the extreme boundary of temporal experience. Massive objects are confined to time-like paths. The architecture of space-time dictates these distinctions, ensuring that light moves timelessly, causality is preserved, and the universe maintains consistency. Light is the ultimate witness to the structure of reality, traveling along the frontier where time vanishes entirely, connecting emission and detection, past and present, across incomprehensible distances, a manifestation of the mathematical backbone of the cosmos. This timelessness is absolute within the geometry of space-time, a principle verified by experiment and embedded in the constants of nature. Light, relentless and eternal in its null trajectory, reveals that time is not a river flowing uniformly for all entities, but a relational, emergent property shaped by motion, mass, and gravity. Space-time accommodates time differently depending on paths taken along null paths. It disappears. This realization redefines our understanding of the universe. The speed of light is the cosmic metric, the conversion factor between spatial motion and temporal passage. Photons inhabit the boundary where proper time collapses, a realm inaccessible to massive observers. Emission, propagation, and absorption are unified in zero-duration intervals. The universe respects these geometric constraints, preserving causality, motion, and energy transmission. Light embodies the ultimate principle of physics' existence along the frontier of time, connecting events without aging, racing across the cosmos along paths where the passage of time is mathematically null. Reality seen through this lens is a structured, geometric, and counterintuitive domain where light alone occupies the edge of temporal experience, timeless yet dynamic, connecting the cosmic narrative in a continuous, unbroken chain of null intervals. Photons are the messengers, the boundary markers, and the ultimate proof that time is flexible, contingent, and relational, revealing the extraordinary structure of space-time and the limits of human perception. Light is timeless because space-time demands it. It moves along the frontier where proper time vanishes, and in doing so exposes the deepest truths about motion, causality, and the fabric of the universe. Beyond flow is time an illusion? Having established that time stops for light and explored the geometric and physical reasons behind it, we must now confront the most profound implications, the nature of time itself, and what it means for the universe. If light moves timelessly, special and general relativity reveal that time is not universal, absolute, or unyielding. Instead, it is relational, contingent on motion, gravity, and the structure of space-time. Two observers moving relative to each other will disagree on simultaneity. Clocks in different gravitational potentials tick at different rates. Massive objects trace time-like paths through space-time, experiencing proper time. Massless particles traveling at c follow null paths where the proper interval vanishes. Yet human perception, rooted in everyday velocities in the weak gravitational fields of Earth, imposes the illusion of uniform linear time. Feynman emphasized that the role of intuition is limited. The universe obeys the mathematics of physics, not the sensibilities of evolved organisms. From this perspective, light serves as a probe into the extreme structure of reality. A photon emitted from the surface of a star billions of light years away travels to Earth along a null path. In cosmic coordinates, eons pass, galaxies form and die, civilizations rise and fall, but along the photon's space-time trajectory, no time elapses. Emission and absorption are contiguous events, neighbors in the geometric fabric of space-time. This is not metaphor, it is the precise prediction of relativity. The universe is stitched with these null connections, creating a web of causal influence that is timeless from the perspective of massless propagation, yet fully embedded in the temporal evolution observed by massive entities. Quantum mechanics reinforces this picture while adding layers of complexity. In Feynman's path integral formulation, photons do not follow a single trajectory. They explore all possible paths between emission and absorption, each path contributing a probability amplitude. Interference patterns arise from the superposition of amplitudes, yet the invariant speed of light ensures that the dominant contributions align along light-like paths. Even in a universe of quantum uncertainty, the null interval remains preserved. Proper time is zero, timelessness maintained, and the photon continues to connect events across space. This demonstrates the robustness of light's timelessness across classical and quantum frameworks. Cosmology extends the argument further. The cosmic microwave background represents photons, emitted 380,000 years after the Big Bang, now observed billions of years later. From our temporal perspective, they have traveled across the expanding universe, redshifted by the stretching of space. Yet from the geometric standpoint of null intervals, their journey contains no proper time. The universe's expansion alters the path through space. not the passage along time for the photon. Light therefore serves as a bridge between the earliest universe and the present, linking events in a manner that is temporally collapsed along the photon's path. Entropy and the arrow of time emerge from these considerations. The second law of thermodynamics dictates that entropy increases in closed systems, giving rise to the observed asymmetry between past and future. Yet most microscopic physical laws are time-symmetric. Along null paths, proper time vanishes entirely. The photon does not experience directionality. Time asymmetry emerges only for massive observers embedded in thermodynamic processes. Light demonstrates that the fundamental laws of physics need not prefer past or future. The flow of time is emergent, a statistical consequence of boundary conditions and the collective behavior of mass energy distributions. The philosophical consequences are profound. If time is contingent, relational, and partially emergent, then the human perception of a continuous flow may be a cognitive artifact. Space-time itself is a four-dimensional block in which past, present, and future coexist geometrically. The sensation of passage arises from consciousness tracing a time-like path within this block. Light moving along null paths occupies the boundary of this structure, revealing the limits of temporal experience. It connects distant events without aging, traversing the cosmos timelessly, exposing the possibility that time is not fundamental but derivative, emergent from relationships and symmetries within space-time. The invariance of c, the constancy of light speed, and the null interval collectively define the ultimate boundary conditions for causality, information transmission, and motion. No mass can reach this boundary, only massless excitations inhabit it. Gravity further complicates temporal experience. General relativity shows that time dilates near massive objects. Clocks deeper in gravitational wells tick slower. Near black holes, time appears frozen from distant frames. Photons crossing these regions maintain zero proper time, highlighting the separation between the experience of massive entities and massless propagation. Space-time is dynamic, curved, and contingent on mass energy distribution, yet the light-like boundary remains invariant. Energy and mass are interconvertible, as expressed in EMC parallel. Photons carry energy and momentum without rest mass, allowing them to interact with matter, exert radiation pressure, and transmit information, all while remaining timeless along their path. This establishes a dichotomy. Motion, energy, and causal influence persist, yet the passage of time is suspended. Relativity, quantum mechanics, and cosmology converge to demonstrate that light's timelessness is a fundamental property of the universe, not a special case or approximation. Observing light from distant stars or cosmic microwave background radiation is witnessing a bridge across the temporal dimension, compressed to zero proper time. This has implications for the nature of causality and information propagation. The universe is interconnected through null paths, preserving causal structure while allowing massless entities to traverse vast distances instantaneously in their own geometric measure. Human intuition fails to grasp this because we perceive time only through time-like experience. Feynman emphasized calculation and experiment over intuition. Reality does not bend to human expectation. Light embodies this principle, adhering strictly to the invariant laws of physics, revealing the architecture of space-time at its extremes. Considering these principles in combination, the universe can be envisioned as a four-dimensional block in which events are laid out geometrically. Massless entities traverse null paths linking distant events, and massive observers trace time-like world lines experiencing proper time. Time emerges as a relational and contingent quantity, experienced differently depending on motion, gravitational field, and position. Light exists at the edge of temporal experience, moving along paths where duration vanishes, connecting emission and detection, past and present, across the cosmos without aging. Quantum uncertainty, space-time curvature, and cosmological expansion all operate within this geometric structure without altering the fundamental null interval for photons. The invariance of C defines the ultimate limit of motion, the frontier of temporal experience, and the structure of causality. Proper time is zero along null paths. Massive entities remain constrained within time-like paths, unable to reach the boundary, forced to move inevitably through time. Light, relentless, timeless, and constant, demonstrates the extraordinary nature of space-time, revealing that time is not universal, that the flow of moments is contingent, and that the universe is structured by geometry, not perception. The photons we observe from stars, galaxies, and the early universe serve as cosmic messengers, timeless bridges connecting events across space and cosmological epochs. They are witnesses to a universe where time can vanish, where motion continues unimpeded, and where causality is preserved through geometry. The null interval is the ultimate measure of temporal collapse, and the speed of light is the conversion factor linking space and time. Light's journey illustrates that the universe is fundamentally geometric, causal, and counterintuitive, with time emerging as a derivative property experienced only by entities with mass. The implications are both scientific and philosophical. If time is emergent, if proper time can vanish along light-like paths, and if the universe is a block in which events coexist geometrically, then human perception of a flowing present is a narrow, limited perspective. Reality operates according to the invariant structure of space-time, and light provides the ultimate expression of this principle. It moves timelessly, connecting points separated by billions of years in cosmic time, yet compressed to zero duration along its path. The universe is stitched together by these null connections, preserving causality, allowing the propagation of information, and defining the maximum speed at which influence can travel. Massless particles like photons occupy the boundary of time, motion, and information. They exist at the frontier where proper time ceases, demonstrating the limits of temporal experience. Everything else endowed with mass moves through time along time-like paths, unable to reach the boundary and forced to move inevitably through time. Light, relentless, timeless, and constant, demonstrates the extraordinary nature of space-time, revealing that time is not universal, that the flow of moments is contingent, and that the universe is structured by geometry, not perception. The photons we observe from stars, galaxies, and the early universe serve as cosmic messengers, timeless bridges connecting events across space and cosmological epochs. They are witnesses to a universe where time can vanish, where motion continues unimpeded, and where causality is preserved through geometry. The null interval is the ultimate measure of temporal collapse, and the speed of light is the conversion factor linking space and time. Light's journey illustrates that the universe is fundamentally geometric, causal, and counterintuitive, with time emerging as a derivative property experienced only by entities with mass. The implications are both scientific and philosophical. If time is emergent, if proper time can vanish along light-like paths, and if the universe is a block in which events coexist geometrically, then human perception of a flowing present is a narrow, limited perspective. Reality operates according to the invariant structure of space-time, and light provides the ultimate expression of this principle. It moves timelessly, connecting points separated by billions of years in cosmic time, yet compressed to zero duration along its path. The universe is stitched together by these null connections, preserving causality, allowing the propagation of information, and defining the maximum speed at which influence can travel. Massless particles like photons occupy the boundary of time, motion, and information. They exist at the frontier where proper time ceases, demonstrating the limits of temporal experience. Everything else endowed with mass moves through time along time-like paths, unable to reach the light-like frontier. The universe is built this way by design of its geometry, enforced by the Lorentz transformations, and verified by experiment. Photons we observe from stars, galaxies, and the early universe serve as cosmic messengers,